working accelerate progress quantum computing. This is guest post, IEEE Quantum Week. Expressed here are solely those others, not representations. Few fields invite as much as type quantum computing. Most people understanding the quantum physics extend to fact that it is unpredictable and powerful, almost existentially strange. A few years ago, the spectrums of the updated state of quantum computing look at both positive and negative across the industries. And just as back in 2019, I remained enthusiastically optimistic today. I remain enthusiastic optimistic, even though the hype is real. Outer space actually results much has been accomplished. First is address hypes. Over the past 5 years, this has been the undeniable hype around quantum computing. The heap around the approaches, timelines, applications, as far as back. In 2017, vendor claiming the commercialization technologies were just a couple of years, like announcement. 5,000 qubit system, 2020, was even rather than the called anti-heap was the some question quantum computers. More recently, companies shift their timelines a few years to the decade. They continue to release commercially viable system. As early as 2029, this is heap-fueled expectation becoming the institutional department. The Department of the Homeland Security even released a roadmap to protect against the threats quantum computing. In the efforts to help institutions transition new security system, this is create far behind mentality for both quantum computing. Market research, heap cycle, believe quantum computing may have already reached peak heap. Phase 2 of the 5-phase growth model. The main industry is enter phase called through this illusions according to the company. And quantum computing is expected between the 2025 to 2030, based on the announced halfway roadmap. The gate-based quantum computing player believe this is not entirely realistic, as we still have a long journey to achieve quantum practically and draw and points. My opinion, quantum practically is likely still 10 or 15 years. However, progress so on. So semiconductor technologies has taken decade progress to the current state, accelerating each term. So we expect similar advancement with quantum computing. And in fact, we are discovering what I have learned. The wide engineering transistor in India also helping speed quantum computing development work. For example, when developing the silicon side qubit, leverage existing transistor manufacturers infrastructures ensure quality speed fabrications. We have started mass productions qubit to 300 millimeter silicon, so on. So semiconductor create cryogenic quantum controller chip, which is helping to resolve the interconnect challenges associated with quantum computing, eliminating much of the cabling and the today cloud refrigerator. So our experience testing semiconductor development of the cryo-power system. So recent quantum issue of the entanglements of logic qubit, so on. The Intel engineering are working